So what we have today is a quick review of the first test for General Chemistry 2 this spring 2020. As you can see, this is the answer sheet for the first page. And the true and false, 563 Fahrenheit is 568 Kelvin, which is of course higher than 563 Kelvin. All atoms, not hydrogen. Hydrogen does not have neutrons in its nucleus. Yes, the substance in greatest amount in the solution is usually considered the solvent. All light moves at the speed of light, so they move at the same speed. And yes, you make molecules by adding two or more atoms together. Problem 2, of course, is a straight stoichiometry problem. You have to take the 10 grams of ethane, that's the correct name for that compound is ethane, which has a mass of 30.08 grams per mole, turn it into moles. You then have to use the mole ratio, and then you have to change from hydrogen fluoride back into grams. And the hydrogen fluoride has a molecular weight of 20 grams per mole. The first equation, it's simply a double exchange reaction between the ions, the lead and the phosphate, form lead phosphate, but that requires 3 leads and 2 phosphates. And that leaves you the sodiums and the nitrates, and you form 6 of those. One of the potassium carbonates reacts with 2HCl. You get water, CO2, and potassium chloride out of it. Benzene, C6H6, burns. It takes 2 moles of C6H6, 15 moles of oxygen. You get 12 moles of carbon dioxide, 6 moles of water out. On to page 2. On page 2 we have the definitions. A spectator ion is an ion present in solution that does not react. A compound is a chemical combination of 2 or more elements. A weak acid is an acid that ionizes less than 100% in water. Lots of people put a larger sign on there. You got to pay attention to which way that points. And releases only some of its H+ in solution. The Pauli exclusion principle says that an orbital can only hold 2 electrons and their spins must be paired. And finally, the ground state is the lowest energy state available. Problem 5 is simply a molarity problem. When you dissolve potassium sulfate in water, you get sulfate ions and 2 potassium ions. So 12 grams of potassium sulfate divided by 174, its formula weight. There are 2 moles of potassiums in each potassium sulfate, so you have 0.13772 moles of potassium ions. They are in 0.175 liters of solution, so that solution is 0.787 molar potassium ions. Give the ground state electron configuration for phosphorus. 1s2, 2s2, 2p6. That would be, of course, a neon inner shell. 3s2, 3p3. For cobalt, inner shell is argon at 18. 4s2, 3d7 gets you to 27. For strontium, it's krypton inner shell, 5s2, since it's in the 5th row. And finally, for thallium, xenon inner shell, 6s2, 4f14, 5d10, 6p1 finishes off. And so on to page 3. Multiple choice. Everybody loves multiple choice. A barium 138 plus 2 cation has to have 56 protons because it's barium. If it's got 56 protons, it has to have 82 neutrons to be 138. And if it's a cation, it has 2 less electrons for 54. That's A. Silicon. Atomic number 14 has how many valence electrons in its ground state electron configuration? Well, it's in column 14, which tells you that it's got 4 valence electrons. That's C. Which of these has the lowest ionization energy? The trend on the periodic table is down and left for lower ionization energy, and so cesium is the one that is molted down and left. It should have the lowest ionization energy. Which of these is an empirical formula? That means it can't be divided up into a lower ratio set of numbers. And that's the only D. is the only one that is not divisible by something. And finally, which of these is the largest diameter? Again, the trend is down and left is larger diameter. And so the rubidium at C is the one that is furthest down and left. What is the frequency of a photon of ultraviolet light with a wavelength of 74.4 micrometers? Well, for the speed of light, frequency is the speed of light divided by wavelength. The speed of light, 3.0 times 10 to the 8th meters a second. The wavelength, 67.4 times 10 to the minus 6th. Micro is 10 to the minus 6th meters, so 4.45 times 10 to the 12th per second is its frequency. And finally, a stoichiometry problem in solution. A bunch of people started doing that as a dilution. You can't get the right answer doing it as a dilution. In solution, you get to moles by molarity times volume. And so, third step in a stoichiometry problem is mole ratio. So we're going to need 5.24 times 10 to the minus third moles of HBr to run the reaction. You get to volume by dividing moles by molarity. It's 0.108 molar HBr. And so it requires 48.5 mLs to titrate that much calcium hydroxide solution. Unfortunately, while I can give you the answer sheets, I'm not going to be able to send your test back to you. You're just going to have to try and remember what you did on the test. As far as scores go, I have posted the scores and assigned a grade to you, so you have a midterm grade at the moment. We'll have to see how that shakes out in the end. It depends how many other things I can do the next couple of weeks when we go to remote teaching. Anyways, that's it for today, and I hope you are enjoying your time off so far.